All right, go ahead, your textbooks open to page 38. Textbooks open to page 38, and you had homework from two sections on this page. There's the practice 1.6 at the top, the review 1.6 kind of in the middle, and then at the bottom is a review of polynomial arithmetic and factoring, which is kind of a big test review section. And you'll work on just a little bit of that for homework this evening. Page 38, though, the top was the 1 through 9 odd. And then on the middle section, you had 1 through 12 all. We're actually going to look at the 1 through 12 first. So on your homework, find where you have the 1 through 12. Those are the first answers that we will be going over together. All right. So starting with the review, 1.6 in the middle of page 38. Number 1, you're factoring that quadratic trinomial backwards FOIL, Abby.
A plus 2 times a minus 5.
Good. A plus 2 times a minus 5. Number 2, another backwards FOIL, Maddie.
X plus 10.
You did that on purpose, too. She got this smile on her face like, ha ha ha, he called on one with a 10. X plus 10 times x plus 2. You put a little extra southern in there. It is correct, though. Good job, Maddie. Number 3. Kendall, what did you get for your answer?
2x plus 3 times 2x minus 8.
Well, I'm thinking about your answer. I say looking at your answer. I'm visualizing your answer. 2x plus 3 times 2x negative 8. And I noticed that right here, there's a common factor of 2. But there's not a common factor in there. So I already know, even without doing outer inner, this can't be right. Maybe not 3 and 8. You know, maybe instead of 3 and 8, maybe it's for the 24.
4 and 6.
But wait, you can't put a 4 or a 6 in either. Okay, so maybe it's 2 and 12?
Yeah.
Wait, can't put a 2 or a 12 in either of these. Maybe it's 1 and 24. But you can't put you realize the problem? It's the 2 and 2. So let's go back to, you said you got a 3 and an 8. Let's try those again. And maybe instead of 2 and 2, let's try
4 and 1.
4 and 1. All right, now let's try the outer inner. Outer gives us?
Negative 32.
And the inner?
Positive 3.
Combined to get?
Negative 29.
And that's exactly what we wanted, was a negative 29x. So this is our answer for number 3. Number 4, Michael.
5d minus 1 times d plus 9.
Good. Again, my initial thought might have been 3 and 3 until I realized I'm shooting for a 44. That's a really big number considering you have single digits on the outside. So that also might make me think I want the 1 and 9 there. Good job. D positive 9 and 5d negative 1. Number 5, no denominator. How would I write that, Audrey?
2a to the negative 4th, b squared, c to the negative 4th.
Excellent. 2a to the negative 4th, b squared, c to the negative 4th. We just divide the numbers to get the 2. The a to the 6th moves up and becomes a to the negative 6th. Or you could say divide to get a to the 4th in the bottom, then move it up as a to the negative 4th. The b to the 4th cancels with the b squared, just keep b squared in the top. C, the same kind of thing happens. The c and c to the 5th cancel, get c to the 4th in the bottom. Move it up to become c to the negative 4th. Number 6, Genesis.
15mx to the negative 6y negative 1.
Great job. 15m x to the negative 6th, y to the negative 1st. Number 7, raising to a power. Brandon.
I got 64x to the 6th and y to the 18th.
Great job. 64x to the 6th, y to the 18th. Number 8, class.
0.
Oh.
DC.
1. Anything to the 0 power equals 1, not 0. All right, number 9. Hey, but I like the confidence with which she said it. I just don't like the answer she said with confidence. Anyway. All right, number 9. How would I write x is less than 32? Kendall?
32 minus x.
Not with the word is. If it just said x less than 32, it is 32 minus x. But it says x is less than 32.
So x minus 3.
Maddie?
Nope.
Oh, she got it. Never mind.
X equals, right? No? No?
But it doesn't say it equals 32. It's less than 32. So I literally need to draw
Oh, less than sign.
There we go. And we have to use the less than. So just x less than 32 doesn't mean 32 minus x. X is less than 32. We use the less than symbol. How about number 10? Now notice it doesn't say is more than. It says 1 more than the product of 3 and x. Maddie?
3x plus 1.
3x plus 1. Number 11, the sum of a and b, Michael.
A plus B.
A plus B. And number 12, the difference between 20 and B. Audrey.
20 minus B.
20 minus B. All right, anyone go 12 for 12 on that homework section? 12 for 12. Several, about maybe 10 or 11. You only missed one or two? Only missed one or two? Do we understand the one or two that we missed? Any questions at all? All right, let's take a look now at the 1 through 9 practice at the top of the page. And last lesson introduced this idea of factoring larger polynomials with 4 terms or 6 terms. And Genesis, we said to factor a 4 or 6 term polynomial, we're going to use something called grouping, where instead of looking for a common factor throughout, we just group into binomials, or today I'm going to show you even possibly trinomials, and within the group we try to find a common factor. And the goal of finding the common factor in each group is to reveal then a common, not monomial factor, but a common binomial factor, or as we'll show today, even perhaps a common trinomial. Let's go ahead and take a look at what we did on 1 through 9, the odd. And number 1, we had an x cubed, positive x squared, positive 2x, positive 2. And let's have Genesis take this first one. What do we need to do? Walk me through it.
Take out the common factor of the first term. Or, well, how do I write that?
Well, let's say we group our first 2 terms
The
together.
first 2 terms together. And then the x to x.
We're not multiplying them, we're just kind of grouping them, like as if we put parentheses around them. But within that grouping, we then want to pull out x squared. So we want to look at the group here and pull out the x squared from the group to leave us with
X plus 1.
x plus 1. And we're going to do the same thing with the next 2 terms. We're kind of going to group them together, but as we group, we're going to pull out the common factor of
2.
positive or negative 2. Because whatever the first term is in the group, that's the sign we're going to keep. So here we're going to take a positive 2, and in parentheses.
X plus 1.
So now instead of 1, 2, 3, 4 terms, Genesis, we now have 2 terms. This is all 1 term. This is all 1 term. And now we're done with the common monomial. Now we're looking for a common binomial.
Oh, then x plus 1.
And we can pull out the x plus 1. And when we do, it leaves us with what?
2 plus x squared.
Or better yet, let's leave it the order it is right now, x squared plus 2. And it's not, it wouldn't be wrong, addition's commutative, but this would be our answer. How many had this for number 1? All right, let's take a look at number 3, where we had an a cubed, negative 4, a squared, negative 11, a positive 44. Brandon, talk me through it.
Group the first 2 terms and the last 2 terms. And then you'll take the common factor a squared, in parentheses a minus 4r. Oh, not r.
Did you say 4r?
Little dash. But then negative 11 and in parentheses a minus 1. And then you take your common binomial, a minus 4 and a squared minus 11.
There we go. Are we finished factoring, or can we keep going, Maddie? We are finished. This is not a difference of squares. If this were a squared minus 4, a plus 2, a minus 2. If 11 were a square, sure, some indifference, but we're done. How many got this answer for number 3? Number 5, we've got a negative 4, a positive q cubed. That's a fun one. Positive 4q, negative q squared. Abby, talk me through this one.
You group the first 2 amongst.
And as she says it, she begins to hesitate. Her voice falters as she realizes, no, wait, he tricked me.
Descending order.
Let's get it in descending order. Couldn't fool you for long though, right? We get descending order. We got the q cubed, then the negative q squared, then the 4q, then the negative 4. All right?
Group the first 2 and last 2. And then, actually, before the parentheses, q squared.
That's a horrible q. Q squared.
And then q minus 1. Positive 4. Q minus 1. And then you take the common binomial and put it down to q minus 1 times quantity q squared plus 4.
All right, and are we finished factoring this time, Abby?
No.
Okay, because we can, what,
Wait, that's sum of squares, so.
Good. This is a sum of squares, so
So you leave it?
you leave it alone. It doesn't factor anymore. Difference of squares factor sum and difference. Sum of squares, leave it alone. We are finished right here. How many have this answer? On number 5. Questions. Questions. All right. Numero 7. We got a 2ar squared minus 14r squared, positive 4ar, negative 28r. Kendall, thoughts?
You factor out a 2. Wait, no. You would. No. So you group, right?
Sure.
Yeah.
I'm looking at like trying to do a descending order thing, and I'm like, that's really kind of hard here, right? To do a descending order. Now, technically, this is a third power term, a third degree term, because there's a total exponent of 3. Here's second degree. This is also second degree, but the r is still less, and then this is first degree with a lesser r. So technically, this is descending order, but if it's just not obvious what you're doing, maybe just leave it like this for now. So let's group the first 2 terms, and then?
And then you factor out a 2r squared.
Good. Now, she started to comment, there is a 2r in everything, isn't there, that you could pull out. But I told you before, it's going to be easier if you'll not do that at the beginning, but perhaps wait till the end.
And then in parentheses, do a minus 7.
Okay?
And then you pull out a positive 4r. And then in parentheses, a minus 7.
All right. What's common to these 2 terms?
A minus 7.
And?
And 2.
And?
R.
In these 2 terms, there is a 2, there is an r, and there is an a negative 7. So if I pull out all of what's common, Kendall, what's left when I divide all of this by that?
R.
R. What's left if I divide all of this by that?
Positive 2.
Positive 2. And we're done. Now, what if you said, well, I've got an a negative 7, and that leaves me with 2r squared positive 4r. Then you could still see the 2r here, pull it out, and leave yourself with the r plus 2. So there are a number of ways to get to this answer. Again, is it wrong to pull out the 2r right from the get-go? No. Some math teachers would say that's better. I'm lazy. I think that's the easier way. How many got this answer regardless of which way you approached it on number 7? Oh. Well, good job, Kendall. Good. Okay, the rest of you who didn't miss a week of class. Questions? Show off. Just as like, obviously the secret to success is to be gone. I'll leave. She watched the lessons on YouTube though. See, yeah. And Brecken and Gavin are like, yeah, we got it too. We got it too. See? All right. Questions on this? All right, number 9's our last one. And let's go to Michael for this one. Class acts like they're not expecting much. Like they're disappointed in him or something. What? I notice your sister's not rushing to defend your reputation. All right, Michael, prove them wrong. What do we need to do here?
Group the first 2 terms and group the second 2 terms. You need to take out an A and a C for both terms. For the first one, then that leaves with 15A minus 4. Then you take out a negative 2AB. And in parentheses, you have a 4 plus 15A, negative 15.
Is 15a minus 4 class the same thing as 4 minus 15a? No. Subtraction's not commutative, right? For them to match, just as this 15a is positive, that would have to be positive. Just as this 4 is negative, this 4 would have to be negative. These 2 signs would have to be different than what they are. Anyone thinking back to Algebra 1 perhaps remember how we could make that happen.
At the inverse.
By doing what? When do we add the inverse? When we
Multiply.
Health class? Subtract. If I could change this to, instead of a negative 2ab, subtracting the negative 2ab, or adding the inverse, that would change both signs. And this is one way to approach the problem. There is a way that I think is a little bit more direct, though. Third power, third degree, second degree, third degree. Here, if I just pull this term to the front, I think it's going to make the whole process easier. Does that make sense? So you could, from where Michael left us off, we could change this sign, which would also change these signs. And now, yes, they both say 15a, negative 4. 15a, negative 4. And we could make them match. But I think if we restart the problem and maybe get that descending order, the highest degree at the beginning, and then the lower degrees later, let's try that and start over. And see if this way just doesn't flow better. Michael?
Group the first two terms. Group the second two terms. Take out a 15a, and that leaves you
More than just 15a.
with a squared.
15a squared.
That leaves you with 2b and then c. Now subtract and take out a negative 2a. 4a. That leaves you with a 1c, a c, just c, and then a positive 2b.
Ooh, question class, is 2b plus c the same as c plus 2b? Yes, they are the same. Now, Michael's going to have to choose which way to write these, but when he pulls out his common binomial, he can write it either direction. It's fine. But there's not just the c plus 2b or 2b plus c that's common. What else is common, Michael?
A.
An a. So I can pull out an a and
2b plus c.
2b plus c. And in parentheses, it'll leave us with
15a minus 4.
And again, we would have gotten to this point the other way also. We would have just had to change the signs by changing that other sign. Did anyone happen to get this answer? Great job, Brandon, okay? It took some things we talked about in Algebra 1 but had not talked about yet this school year. So quick reminder to you. If you've got, say, a 3a negative 4, and you want the 3a to be negative and the 4 to be positive, change the signs, and then change what's out here. Or, if we already had a negative, and you wanted these signs to be reversed, positive and negative, change what's out here. And the problem's taken care of that way. Or, like I say, if you get the descending order, the problem takes care of itself. Questions on the 1 through 9 odd. I know those last couple were a little bit more challenging questions. All right, now that we've seen those, now we're like, okay, yeah, I remember how to do that. Okay, yeah, that makes sense how to do that. Now we'll go ahead, nope, not now. Yeah, let's do it now. Well, let's do it now. Page 38, 2 through 10 even. That was actually number 3 on the plan, but we'll go out of order here. Do 2 through 10 to even now. They're on page 38. So we did the odd for homework. Let's go back and do those evens now. And watch for that descending order. And another way to have looked at the last problem is the a squareds at the beginning, the a to the first later on. In this example here, class, r squares at the beginning, r to the first later on. just in about another minute or so. If you're finished, check your answers to 2, 4, 6, and 8. If you're not finished, don't check. Keep working. All right, pencils down. Even if you're not finished, check your answer to number 2. I don't think it can get much easier than what we see on number 2. How many got number 2 correct? All right, number 4, the only weirdness is in that you have to pull out a negative x squared and a negative 121, which when you pull out the x negative 2 then gives you negative x squared negative 121. Flip-flopping doesn't do a thing for me, right? So the only option is to factor out the negative sign. But when you factor it out, bring it all the way to the front, and that changes both of these to positives. How many got negative x negative 2, x squared positive 121? Okay, those who missed it, was it just the negative that kind of threw you off? Okay, questions on that? Questions on that? The next one, yeah, really straightforward. Once you get it in descending order, right? Rewrite in descending order. How many got this for number 6? Good, perfect across the board. Number 8's a fun one. When we group the first 2 terms, there's a negative 8, a b squared, and a c all common. Gives us 4b negative 3. In the last 2 terms, we just have the positive 3. C gives me 4b negative 3. So in these 2 terms, we have a c and the 4b negative 3 that's common. Pull both of those out, and that leaves you with the negative 8b squared positive 3. Now you can't leave it like that because you can't have a negative first term. So option number 1, move this out of the way, option number 1 is just flip-flop these. Put the 3 before the negative 8b squared. We're good. All right, that takes care of the first term negative issue. Or, like we showed here, pull out this negative sign all the way to the front, and then it changes both signs. It makes this become positive and that become negative. That's your other option. How many had one of those answers on number 8? All right, those who did not, questions. Does it make sense now? All right, let's take a look at number 10 together now. And how many finished number 10? How many able to finish number 10? Most of you, good. Let's take a look. And numero 10. I'm seeing a weird order. Like there's y's everywhere, but I'm looking at the x's. Do you see the x's are all over the place? I'm going to start off by putting my cubed x at the beginning. There's my 4th degree term, then the 42x squared y, then the 32xy, and then the 56y. Okay, so that gives me a descending order here. How many saw to rearrange it? You may be able to do it without rearranging, but it's sure going to be easier, I think, this way. Let's see, what's common here, class?
24x squared y.
Well, there's not a 24 in 42, not evenly.
6.
There is at least a 6, though, and
Squared.
okay, so I pull all that out to leave me with
4 plus 7.
all right, and then right here, what's common?
8y.
Got an 8, and I got a y. Yep, so positive 8y leaves me with.
4x plus 7.
The good news is you kind of knew it should be a 4x plus 7, right? So that kind of helps guide your thinking. Now, be very careful. In these 2 terms, there's more than just a binomial that's common. What's common in those 2 terms, Audrey?
4x plus 7.
Well, yes, there is a 4x plus 7. What else?
Y.
The y's and a 2 in both the 6 and 8. So if I pull out a 2, a y, and a 4x plus 7, what's going to be left is I divide this by the 2y 4x plus 7 and this by the 2y 4x plus 7, Audrey.
3x squared plus
And then over here when we divide we get
plus 4.
plus 4. And there we go. And there's our answer. How many had this for number 10? Good, a few of you did. Those who didn't, questions. All right. Any questions at all on this factoring by grouping? All right, we'll revisit that topic here in just a moment. For now, let's go back to what we were supposed to do before we did these, but I can't seem to follow a lesson plan. That's some basic classwork for you. Just some review of other forms of factoring, then we'll go right back to grouping again, but maybe it's better this way, break up the monotony of grouping. First thing we should always check for when we factor, class? Common factor. Always check for that common factor. Now, in the case of grouping, if we see the common factor, we tell ourselves we don't wait, okay? But we're also going to see it come up later. If we have a trinomial, we ought to first ask if maybe it's a perfect square trinomial. If it is, class, it would become a binomial squared. If it's not a PST, maybe it's another type of trinomial. What's the other type of trinomial we talked about? Quadratic. And if it's a quadratic trinomial, class, we would factor using backwards FOIL, right? If it's a binomial, though, my first thought is, well, maybe I've got a difference of squares. And if I've got a difference of squares, class, it would factor into a sum and difference. Maybe I don't. Maybe I've got a sum or difference of cubes. Binomial times trinomial. Or maybe at least sum or difference of same odd powers. Binomial times polynomial. All right, at your seats, I want you to factor these 5 polynomials. As you factor each one, before you circle the answer, ask yourself, is there anything more I can factor? For instance, if you were factoring, say, a 30, and you said, oh, that's 3 times 10. Well, there's more to it. You could factor the 10 into 2 times 5. We're looking to factor as completely as we could. Though monomials, of course, will be simplified. If you're stuck on one, move on. several people finishing up here. Maybe take one more minute or so to finish. If you're already done, check your answers. See how you did. All right, pencils down even if you're not finished at this point. Looking at the first one, not a PST, pretty obviously. Quadratic, right, backwards FOIL. By the way, it's not AZ squared and AZ squared. It's A squared Z squared, A squared Z squared. Each individual letter needs to be squared there. And then, plus 7, minus 4. But perfect square minus perfect square there at the end, difference of squares factor into the sum and difference. So keep the A squared Z squared plus 7, then get the AZ plus 2, AZ minus 2. How many took it all the way to the end? How many of you stopped one step too soon? Questions. Again, watch those fourth powers. The next one's just like too easy to be easy. Like you pull out your common factor of 2x squared, leaves you with 4x minus 1, you're like, there's got to be more. There's not. It's not a difference of squares. It's big nothing. You even look at like the 8x cubed, you're like, I'm smart, 2 cubed, x cubed. I see difference of cubes coming. It's just a big nothing. How many got that answer on the second one? All right, perfect. None of you thrown off by it. The 6 4 a minus a to the 7th, pull out the common factor. Be careful. You might be tempted to say, ooh, 2 to the 6th minus a to the 6th. Binomial, polynomial. That's for odd powers. These are even powers. Even powers are squares. So factor it into a sum and difference. 8 plus a cubed, 8 minus a cubed. Now think in terms of 2 cubed and 2 cubed. Sum of cubes, difference of cubes. I went ahead because the proper order to list factors is monomial, then any binomials, then trinomials, then if you have 4-term polynomials, whatever kind of craziness forms. Smaller polynomials first. So I split this into 2 plus a, and then 2 squared, 2 to the first 2 gone, a to the first a squared, signs alternate because of the positive. Then here 2 minus a, same thing but with all positives. How many got this for number 3, the third one? Ooh, okay, questions on this. How many fell into the 2 minus a and then the 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared? Anyone do that? Got a few of you, a few guilty people, okay? How many at least got to this point? You didn't do it the wrong way, but you just stopped too soon. Okay, questions. All right, on the next one, common factor of 5. Okay, backwards FOIL. Yeah, once again, those fourth powers, difference of squares, sum and difference. How many took it all the way to the end? Excellent. How many stopped one step too soon? All right, questions. And on the last one, no common factor, but you got the backwards FOIL. Careful, don't try to factor the sum of squares. Not b plus 2b minus 2. Leave the sum of squares. But the difference of squares, sum and difference. b plus 1, b minus 1. How many got that for the last one, those who made it that far? All right, questions on these. Watch out for those fourth powers. All right, write this down in your paper if you would. I want to go back to this idea of grouping and show you a couple of weird things that can happen in grouping. Because after all, this is Algebra 2. Algebra 1, they're trying to keep it to the basics. Algebra 2, I get to show you all the cool stuff. And little weird tricks and things like that that'll come up. So write this down, 3x minus by minus 3y plus bx. Well, 4 terms, what should we be thinking, class? Grouping. And so I look at my first term, my first set, and I look at my second set. What's common in the first set, class? Nothing. Well, you might recall from Algebra 1, I said if nothing's common, you can factor out a 1, right? But what about in the second set, class? Nothing. Another 1, or in this case a negative 1, but that still doesn't give me anything common that so it doesn't factor by grouping, right? Thoughts? Audrey looks like she wants to speak. Audrey, speak. Speak, Audrey. Good girl. If I rearrange the stuff, how might we rearrange? There's a lot of different ways you can go with this.
3x minus 3y minus by plus bx.
So get the things with 3's together and get the things with b's together is the thought, right? Now, I will point this out. We get our 3's together, the x and then the y. We get our b's together. It might help if we got the x and then the y. So maybe transpose these two. As you get your b's together.
Plus bx minus by.
Right, and now the factoring should be really obvious, right? We class in the first group, we pull out the, to leave ourselves with x minus y. In the second group, we pull out the b and leave ourselves with x minus y. And sure enough, we factor out the common, which is x minus y, and that leaves us with 3 plus b. Right, but the key was rearranging it to get something that can factor out. Nothing comes out, nothing comes out. We'll get these together so the 3's come out. What's another way we might have been able to rearrange this? Michael?
You could have combined the y's and the x's.
Right, okay, so maybe write it...
Negative by minus 3y, positive 3x plus bx.
All right, and so that then we see what common here?
Y.
Well,
negative
y to leave ourselves with
b plus 3.
and then here we see
X. B plus 3.
technically
3 plus b.
3 plus b, but since that's the same thing, we could say there is a common,
Binomial.
which is
B plus 3.
b plus 3 or 3 plus b, either way you want to say it, doesn't really matter. What are we left with, careful here, when we pull out the b plus 3 or 3 plus b?
Negative y, positive x.
But I know I don't want to write negative y, positive x.
You write positive y, negative x.
Ooh, I can't do that either.
Negative to the front.
Well, you could. That's okay. You could. If you put the negative y, positive x, then you could pull the negative out to the front and make it a positive y, negative x. I was thinking of something a little more straightforward.
Switching them.
Yeah, let's just switch them. I'm lazy. Let's just put the x first and then the negative y. And now we got it, right? So, I mean, there's other ways you could do it. The point is, make sure there's something that is common in that group. Does that make sense? Write this one down. mx minus nx minus x minus my positive ny negative y. I told you 4 or 6 term polynomials could factor by grouping. Here's an example of a 6-term polynomial. And there's a couple ways you could do this. I see mn gone. So I'm going to actually group in sets of 3 as opposed to sets of 2. What's common to that first group, class?
X.
X. And what's left in the group?
N minus N minus 1.
And in the next group, what's common, class?
Negative 1.
All right, and what's left after we pull out the negative y?
N minus N plus 1.
Did I copy that correctly? I think this was supposed to be a positive y, not a negative y. So that way we would have not a positive 1, but a negative 1. And what's common now, class? Not a common binomial, common trinomial. What is it? N minus N minus 1. And we pull that out and we're left with x minus y, which normally I'd put in the back, but because it's a binomial, it's the smaller polynomial, we have to write it out in the front. So this is one way to approach it, but there's another way. You could say, well, let me put my m's together. mx, negative my. Let me put my n's together. Negative nx, positive ny. Let me put my plain old x and y together. Negative x, positive y. And now I could group little sets of 2, right? And if I group sets of 2, what's common here, class? M leaves you with here, leaves you with. What about here? A negative 1, technically, is all you've got. Leaves you with x minus y. Notice each of these terms has a common x minus y. If you pull out the x minus y, what are you left with? More than one way to do it, right? Questions on 6-term polynomials. Does that make sense? How grouping is rather versatile. Sometimes rearrangings can work. I'm going to give you some that may require some rearranging here. And then we'll be finished for today. Write this first one down. Ax minus a minus bx plus b minus cx plus c. Go and get started on that one, and then I'll have a couple more for you. Check your first two. How'd you do? How many got the first two both correct? You paired them up properly. Good. Keep working on that last one if you haven't already started. And you realize, ew, that's not going to work at all. What do we need to do here, class? Let's get descending order. Let's rearrange these. Here's a thought. Let's get your x squares together. Then maybe get your x's together. And then your no x's together. Or get all your b's together and then all your y's together. Does that make sense? Stay with me. So we put a bx squared, then maybe a negative bx, then maybe a negative b. If we put an x squared y, then maybe a negative xy, then maybe a negative y. We got all our b's, then all our y's. So obviously here's the b, x squared minus x minus 1. Here's a y, x squared minus x minus 1. And now we can see the common x squared minus x minus 1 times the b plus y. So again, sometimes rearrangings have to happen, even though there was something common each time. But what it left you with ain't no help at all, right? You're going to practice with a little of this for homework this evening. For homework, pages 39 to 40. For homework, pages 39 to 40. Do numbers 33 to 60, the teal. 33 through 60, the teal problems. And 63 and 64. They're not teal, but I want you to do them anyway. Okay, so 33 to 60, the teal, and 63 and 64. We'll take a look at all of that tomorrow as we review for your test in lesson 18 coming up on Friday. Have a wonderful rest of your day, and you are dismissed.